Good morning, children. After a long gap, we are going to restart our mathematics classes. So we will start with a new lesson. It is called trigonometry. Trigonometry. It is an entirely new topic for you. This word trigonometry is the combination of three Greek words: tri, gon, and metron. Tri means three, gon means sides, metron means measurement. So trigonometry is something like the measurements of the sides of a triangle. It is not only the measurement of sides of a triangle, the measurement of sides and angles. There is a relation between the sides and angles of a triangle and all. That is what we are going to study in trigonometry. So let me just tell you some uses of this trigonometry. Trigonometry is very useful in many fields. For example, if you want to find the height of a mountain, or the height of a very tall building, or a tower. There is a tower. You are standing here on the ground. By just knowing this distance, we will be able to find out the height of the tower. Then you can find the width of a river without actually measuring it. Even you can find out the speed of an aeroplane standing on the ground. So all these are some of the uses of trigonometry which you will study later on. So the basics of trigonometry is trigonometric ratios. See, when we study English language, first we study alphabet, 26 alphabets. So like that, when we study trigonometry, we have to study trigonometric ratios. There are 6 trigonometric ratios. So that is the basic thing which we are going to study today. So you know triangles, right angled triangles. Here you can see triangle ABC, right angled at B. ABC is a right angled triangle. You know the sides of a right angled triangle, we call it hypotenuse, base, altitude. Usually these are the names given for a right angled triangle. Right angled triangle. The side opposite to the right angle, which is always called hypotenuse. Then base and altitude. If you take this as base, this is altitude. That can be reversed. You can take this as base also. Then this has to become altitude. But hypotenuse cannot be changed. Hypotenuse is fixed, permanent, and that is the longest side in a right angled triangle. How to identify it? It is the opposite side of the 90 degree. You know, 90 degree is the largest angle in a right angled triangle. So the side opposite to the largest angle will be the largest side. So these two angles are always below 90 degree, or we can say they are acute angles. Now let us come to our figure. So triangle ABC is a right angled triangle, right angled at B. So opposite to angle B, that is hypotenuse. Now we will not call the other two sides base and altitude. So we have taken one of the acute angles A. We have chosen this angle for a purpose. There are two acute angles A and C, but we are taking angle A as our angle. So based on the angle which we have chosen, we will call these two sides some different name. This side BC we call side opposite to angle A, or we can just call short opposite side. Because that side is opposite to our angle A. Now this side which is adjacent to means nearby, the side which is adjacent to angle A, We will call it side adjacent to angle A, or in short we can call it adjacent side. So we have renamed the three sides of a right angle triangle. Hypotenuse we did not change. The other two sides, instead of base and altitude, we called it opposite side and adjacent side. Why it became opposite side? Because we have chosen angle A as our acute angle. Now let us see. Suppose we are choosing angle C as our acute angle. Then what will happen? Then AB becomes opposite side and BC become adjacent sides. So this opposite side and adjacent sides are not permanent. It depends on which angle you have chosen as your acute angle. But hypotenuse is always hypotenuse, no change. Now we will study the six trigonometric ratios. The first ratio, it is the ratio of see here we have taken this figure, angle A as our acute angle. Now the ratio of opposite side to hypotenuse. Opposite side to hypotenuse. So in the figure, what is opposite side? It is BC. BC by hypotenuse is AC. This ratio is called sine of angle A. Sine of angle A. And for this there is a short form, we call it sine A. SIN, sine, we don't call it sin, we will call it sine. It is written in small letters, and that particular angle, that is capital letter, sine A. It is not sine into A, actually it is only the short form of sine of angle A. I hope you understood. It is a ratio only. You have to divide the length of BC by hypotenuse. So this is the first trigonometric ratio. Now the second one, adjacent side divided by hypotenuse. Remember, this is opposite side. This is adjacent side. So here AB divided by AC. This is called a cosine of angle A. And short we will write a cos A. Now the third trigonometric ratio is ratio of opposite side to adjacent side. Here it is BC divided by AB. In that there is no hypotenuse. We call it tangent of angle A, and in short we will write a tan A. Now there is a fourth trigonometric ratio that is just reciprocal of the first ratio, sin A. So what is that? Hypotenuse divided by opposite side. So that will be AC divided by BC. It is called a cosecant of angle A. In short, we will write a cosec A. Cosec A. Remember, that is the reciprocal of sin A, or we can write it is 1 by sin A. Similarly, the reciprocal of the second ratio, that is hypotenuse divided by adjacent side, that is AC divided by AB, that is equal to secant of angle A, or we will call it sec A. Remember, that is the reciprocal of cos, so it is 1 by cos A. Now the last one, it is the reciprocal of the third ratio, so it is adjacent side by opposite side, so it is equal to AB divided by BC, that is equal to cotangent of angle A, and in short we will write cot A, and that is the reciprocal of tan A, so it is equal to 1 by tan A. So today's your main work is to remember to learn the definition of these 6 trigonometric ratios very well, so then only we can proceed. This is just like ABCD in English literature, English language. So without learning this one properly, we cannot proceed. So I will not give you much work today. So you have to study this one, each ratio starting from sin A. What is sin A? It is opposite side by adjacent side, sorry, hypotenuse. Cos A, adjacent side by hypotenuse. Tan A, opposite side by adjacent side. Cosec A. See, actually if you learn the first 3, the next 3 are just reciprocals. So the first 3 you have to learn very well, then we will learn the next 3 as the reciprocal. So all these 6 ratios, its short form, its full form, its definition, everything should be learned today. Okay, then I'll give you some remarks. Some notes. The symbol sin A is not the product of sin and A. It is not like algebra, okay? It is not sin into A. Usually in algebra, if you write without any symbol plus minus and all, its meaning is multiplication. Here it is not multiplication of sin and A. Sin without angle A is meaningless. If you simply write a sin, it has no meaning. So whenever you write a sin, an angle should be written. So sin A is the abbreviation or short form for the sine of angle A. The value of sin A is not depending on the length of sides of the triangle. I will explain to you. I am telling only about sin A. It is applicable to all the 6 trigonometric ratios. See, for example, here you see, let us take this acute angle sin A. So this is the opposite side. PM is opposite side, AM is the adjacent side, and PAP is the hypotenuse. So sin A is equal to PM divided by AP, or it is equal to CB divided by SC also, or it is equal to QN divided by AQ. So these ratios are all equal because you know these are all similar triangles. We have studied already similar triangles. Here you can see 3 triangles, APM, ACB and AQN. These triangles are all similar. You know, similar triangles, their corresponding sides are proportional. So sin A is same whether you take from this small triangle or this medium sized triangle or this big triangle, sin A will be same. That means the meaning of that one is the value of sin A is not depending on the length of sides of the triangle. Since the hypotenuse is the longest side in a right triangle, the value of sin A and cos A is always less than 1 or maximum equal to 1. Because you know sin A is equal to opposite side by hypotenuse. You know hypotenuse is always longer than opposite side. So it is a fraction with less numerator and more denominator. So its value will be always, it is like a proper fraction. So its value will be always less than 1. So the value of sin A and cos A will be always less than 1. But what about tan A? It need not be less than 1. So let us do one problem now. After learning the definition of all these 6 trigonometric ratios, so I would give you one question for practice. In triangle PQR, right angle at Q, find the trigonometric ratios of angle R. So here we have taken this angle R as our angle. So at first what you have to do is you have to name the 3 sides. So first let us name hypotenuse, which is hypotenuse here, PR. I will write H only for hypotenuse. And opposite side, which is the opposite side here, this is opposite side PQ, and QR is adjacent side. Now we have to find out all 6 trigonometric ratios of angle R. So sin R, only one I will find out. The remaining things you have to write. Sin R is equal to, try to remember the definition, opposite side by hypotenuse. So here which is the opposite side? PQ divided by PR. So now you have to find out the remaining cos R, 3rd, 4th, 5th, 6th. I hope you will do it. Okay, so when you do only, that definition will become thorough in our mind. Now let us do another problem. Given tan A is equal to 4 by 3, find the other trigonometric ratios of angle A. See, there are 6 trigonometric ratios. One ratio is given, tan A. So the remaining 5 ratios you have to find out. So in all these problems, what you have to do is you have to draw a diagram first. A right angle triangle you have to draw. Our angle is angle A. So let us take this as our angle. It should be an acute angle. B, C. Here angle B is the 90-degree angle. So AC is the hypotenuse, AB is the adjacent side, and BC is the opposite side. So here what is given to us is tan A is equal to 4 divided by 3, right? But what is tan A? Tan A is opposite side by adjacent side, that is BC divided by AB. Therefore we will call BC is equal to, we cannot write BC equal to 4, but BC will be a multiple of 4. So we will write it 4K, and AB will be is equal to the same multiple of 3, that is 3K. I hope all of you understood. See here, BC by AB is equal to 4 divided by 3. So it's a ratio. So we can't write BC equal to 4, but BC will be a multiple of 4. So we write 4k, and AB will be the same multiple of 3. So AB is equal to 3k. So here we will write this is 3k, this is 4k. Now this AC we do not know. So let us find AC by using our Pythagoras theorem. AC square is equal to AB square plus BC square, which is equal to 3k square plus 4k square whole square. Okay, 3k whole square is 3k into 3k, or you can take the square of each term. 3 square is 9, k square is k square. This is 16k square. So 9k square plus 16k square, that is 25k square. What is that? AC square. Therefore AC is equal to square root of 25k square. What is square root of 25k square? That is 5k. So we got a AC also, that is 5k. So after finding this one, we can find out all the trigonometric ratios now. So let us start finding from sin A. What was sin A? Opposite side, that is BC by hypotenuse AC, that is equal to 4k divided by 5k. K and k cancel, we get a 4 divided by 5. So after sin A, let us find cos A. Cos A is equal to, definition of cos A is adjacent side. Which is the adjacent side here? AB divided by hypotenuse AC, that is equal to 3k divided by 5k, that is equal to 3 divided by 5. Now tan A we already know, it is given. So what is next? The fourth one, it is cosec A. Cosec A, either you can find out hypotenuse divided by opposite side, or you can just find the reciprocal of sin A, 1 by sin A. So sin A was 4 by 5, so 1 by sin A becomes 5 divided by 4. Now sec A is equal to, it is 1 by cos A, so that is 5 divided by 3. Last cot A, it is the reciprocal of tan A. What was tan A? It was 4 by 3. So it becomes 3 by 4. So I hope all of you understood. So today I would not like to take much classes, because you have to study the definitions, and to make you thorough with these definitions, I will be giving you few questions as homework. So the homework is, your exercise, the first exercise 8.1, question number 1 to 5 you can do. So all of you should do it, because trigonometry is a very important topic in your syllabus. We have got actually 2 chapters. This is introduction to trigonometry, then application of trigonometry. I think some 10-12 marks questions will come from these 2 chapters. So beginning, if our foundation is not very good, we cannot understand afterwards in future, because it is a totally new chapter which you have not studied it till now. So I hope all of you will do it. If any doubt is there, we can discuss, you can ask me. So this much only today. So thank you children, have a nice day.